Now we go for the analysis. What we can say, circuit under DC operating condition is like this as it is shown. Now what I can do, I can write the equation ID equals to IDSS 1 minus VGS by VP. Now there are two methods to solve the problem. One is the graphical method. Now how is the graphical method, that I will explain it first, then we'll go for the alternative method. You can say mathematically we can solve the other part. Now in the question they will give you the value of IDSS. This is the resistance RD. They will give you the value of IDSS. They will give you the value of VP. Now this voltage is constant VGG. So value of VGG will also be given in the question. So since you know VGG, we know the relation that VGG is minus VGS. So we know the value of VGS. So when you substitute these values in this equation, you can find IDQ, right? Graphically we'll solve. Now you know IDSS and VP. VP is given in the question, right? So what you can plot the transfer characteristics. What I have told in the previous video, you can draw the transfer character. Suppose say a value of IDS is given as 8 milliamperes and VP is given as minus 4. I am taking IDSS as 8 milliampere and VP I am taking as minus 4, for example. Then I know the relation for VGS is VP by 2. That is, I will substitute in the equation. So I will get ID is equal to IDSS by 4. That is, VP by 2 is this point minus 2 and IDSS by 4 is 8 by 4, that is 2 milliampere. I will get this point. So wherever they intersect, I will get 1 point. Similarly, if you want more perfect curve, what you can say, for ID is equal to IDSS by 2. Value of VGS is 0.3 times VP. So you can get another point on the curve, and IDSS by 2 is 8 by 2, that is 4 milliampere. So for this you will get one more point and then you can draw the curve that will give you the transfer characteristics. Now you know VGG and VGS are same. Now this axis what you have VGS over here and VP over here, and here you have ID in milliampere. Now this equation, you know the value of VGS which is negative. So somewhere if you are getting here, say this is your VGSQ which is VGG, then what you can do is draw a straight line, and wherever it cuts the transfer characteristics, find the corresponding point, that is your IDQ. So this is how you are finding Q point for the JFET. So wherever they are intersecting, that point is your Q point. Here we get Q point from the transfer characteristics. Now what you know one of the coordinate directly, because this voltage source is given in the question, VGG and VGSQ. So you drew a straight line, and wherever it is intersecting, we'll draw a parallel line to x-axis. There we get the IDQ. So we got two coordinates of Q point, IDQ and VGSQ. This is how we are finding Q point graphically. Now how to do it theoretically? What you know the equation ID equals to IDSS 1 minus VGS by VP. As I have told you in the question, they will give you IDSS, they will give you VP, and from the circuit diagram what you have got, VGS equals to VGG. So when you substitute all these values in the equation, what you can find, IDQ. You will get some value. When all these values are given in the question, you substitute over here, you will find the value of IDQ. This is how you can do it mathematically. Now for the question, when you apply KVL to drain to source, from this point to this point, what will be the equation? VDD minus current flowing through the drain is ID, current flowing through the source is IS, and we know ID and IS are same. So VDD minus ID RD, voltage is VDS. So we are living with negative sign, positive negative. So minus VDS equals to 0. So what I can say, VDSQ equals to VDD minus IDQ into RD. So we have found VDSQ. Once you know VDSQ, what we can say, I write the equation, VDSQ equals to VDD minus IDQ into RD. What we can say for source, since source is grounded, voltage at source is 0. So what I can say, question is to find VD minus VS. So what we can say, since source voltage is 0, since VS is 0, VD equals to VDS. So this is how we can find the terminal voltage VD, right? Now if they have told you to find VGS, how we write VGS? VG minus VS, but since VS is 0, your VG will be VGS. So this is how you can find all the voltages at all the terminals of JFET. These are the different ways. What you can say, since Vs is 0, this is very simple to find the voltage at the terminals, right? Now this can be proved with a problem, right? For the problem, keep on watching. In 5 minutes